Alright guys, back with the videos, because we didn't record it when I ran through them the other day on Zoom, the videos for the solutions to Paper 2 Year 10. We'll get straight into it. I'll probably do it in a couple of sections, and they'll be up soon for you to watch it, which you'll have figured out if you're seeing this. So let's have a look. Calculate the value of x in the triangle alongside. Right-angled triangle, so we're going to label our sides as our first step. Always a good idea. That's the hypotenuse opposite the right angle. Opposite the angle we've been given is the opposite side, and this is the adjacent. We've got adjacent and hypotenuse, that's cosine. So the cosine of x equals the adjacent side, 8.2, divided by the hypotenuse, 10.6. X is going to be the arc cos, inverse cosine function, arc cos, of the given angle. Now, if you want to simplify that, make it 4.1 over 5.3, you can. Not necessary though in that one. And then you're just pushing buttons on your calculator. X is approximately equal to 39.32 degrees. Bang. Quick, easy 2 marks, and we move on. Rearrange the equation and then find a to 3 significant figures. Alright, that should be pretty easy. Zm equals a plus b divided by a. I'm trying to make a the subject. I can't have it on the top and the bottom, can I? So I'm just going to I'm going to multiply each side by a. So I'm going to get AZM equals A plus B. We're okay to there. Get all my A's together on one side. So AZM minus A equals B. The one tricky step in this one for some people, how do I join those A's together? If it was 7A minus A, you'd just write 6A, which is really going 7 minus 1, lots of 6. Well, here I've got ZMA minus 1A. So I've got ZM minus 1, lots of A, is equal to b. Just factorising, that's all you have to do. Now you divide by Zm minus 1, and you are there. Zm minus 1. Of course, I have to do the second part. Let z equal root 5, m equal 3, and b equal pi. Substitute incorrectly, so I've got a equals pi divided by, I've got 3 root 5 minus 1. A is approximately equal to, I mentioned this yesterday as well, if it says to go to 2 significant figures, often it's a nice idea to write it to more than 2 significant figures and then show that you know what you're doing with the 3 significant figures. So we'll go 0.55036. That's what it's approximately equal to. So to 3 significant figures, 1, 2. There's my third one. Does it stay as 0 or go up? I check the next digit. 3 says leave it alone. So 0.550. And you're done with that question. Let's move on. Question 3. Calculate the distance of CD. Oh, look, more right-angled triangles. Let's label these. Well, there's one hypotenuse. There's another hypotenuse. Okay, well, this is opposite whichever one I'm using, and I've got a couple of different adjacent sides, but everywhere over here is adjacent for either the big triangle or the small triangle. We're okay with that. I'm looking for CD. If I find, maybe make a note of that, CD is going to be equal to the distance BD minus the distance BC. That's going to leave me with just the bit CD, which is what I'm after. Okay. How can I find BD? Maybe we'll work over here. BD is the entire length here, so that's that entire adjacent side, and there's an opposite side, so I'm thinking of the tan of 30 is equal to the opposite side, 50 over the length BD. That's the adjacent side for the big triangle. Rearranging, you can do it in 2 steps or 1. BD is going to equal 50 divided by tan 30. If I'm doing the same working for the smaller triangle, I'm going to get a similar thing, aren't I? So the tan of 48 equals 50 divided by, and this time for the small triangle it's BC. That's equivalent to saying BC is equal to 50 divided by tan 48. Well, we've got what we need to substitute into our equation. CD is going to be 50 over tan 30 minus 50 divided by tan 48. Now it's just a matter of push some buttons on your calculator and you're there. I pushed buttons on the calculator sometime yesterday, and I get approximately 41.58 meters. Make sure we were given units. Let's use units in our answer. Question 3, look, that's already 5, 9, 11 marks, and you're racing through to a decent result. 33 over 8 minus 2 root 5. So this is something where we've got to rationalise the denominator. I disguised the question a little bit. I gave it a slightly different instruction. Express it in the form a plus b root 5. You can see there's no surd on the bottom of a or b, so we're right to go. We need to rationalise. It's just another way of giving you the same instruction. Looking at it now, I should have said a and b elements of the rational numbers, but we haven't talked about them yet, so that's okay if you don't know what I'm saying there. I'm still going to rationalise. Multiply by the conjugate, 8 plus 2 root 5. Why do we do that? Because we get to use our favourite rule in maths, the difference of two squares, and we like using our favourite rule in maths, the difference of two squares. So doing this multiplication, 8 by 33 is 264, 2 by 33 is 66 root 5, difference of two squares on the bottom, so I'm going to be left with 8 squared minus 2 root 5 squared. If I want to do some factorising up the top, I didn't factorise it yesterday, I'll factorise it today. If you want to see the other working, just go to the previous page. I'll leave them both on the OneNote. That's going to be 66 as a common factor there. What have I got left? 4 plus root 5. And on the bottom I'm going to have a 64 minus 2 squared is 4 times 5 is 20. Okay, getting closer to what we need to have. I might just continue my working over in the next column. That's going to equal 66, 4 plus root 5, divided by 64 minus 20 is 44. We can do a bit of simplification here, can't we? 22 goes into that twice, and into that 3 times. So now I'm going to have 12 over 2 plus 3 root 5 over 2. The other way I could write that is 6 plus 3 over 2 times root 5. So state the values of a and b. A equals 6 and b equals 3 over 2, 1.5. A little bit trickier, that one. Getting into the middle of the exam, you probably just expect a little bit of challenge. But again, very doable for everyone. Nothing there that's particularly controversial at all. This one's just checking your algebra skills. We should be all over this. If we're not all over this, use your time at home to be practicing these. We need to get our algebra skills, so we're not giving away marks for things that we know how to do. We just can't execute properly because we haven't practiced enough. Here, 3, 6, and 4 all go into 12. I'm going to multiply by 12, get rid of those denominators straight away. That's going to make my life easier. Oh, my screen is just cutting out for a sec. It didn't cut out for you. When I multiply by 12, that's my equivalent statement now. So 4 goes into 12 3 times. So I'm going to have 3 times 3b take 5 minus 2 times 5 minus 2b equals, and the 3 goes into 12 4 times, so it's 4 times 3 take b. Expand and simplify, and we're there. 9b take 15 minus 10 plus 4b, be careful of that negative and a negative, making it positive, equals 12 take 4b. Collect my terms together on the left-hand side. I have 13b take 25 is equal to 12 minus 4b. I am going to add 4b to each side, so I've got my b's together, which means I'm going to add 25 to get rid of the 25 from the left. Adding 4b to each side, I am left with 17b equals 37. Simple division, b equals 37 over 17. 5 questions in and flying. Prove that triangle WXV is congruent to triangle ZXY and deduce the values. Well, apologies again if you couldn't quite see all the marks on this. That was just poor photocopying. I probably should have redone it. I didn't realise it had printed quite so badly. It looked fine on my screen. Hopefully you're okay. Let's keep going with the question anyway. So here, WX is supposed to correspond to ZX. Well, WX and ZX are equal. And we were given that. They put little indicators on there to tell us that they were equal. In the same way, Vx was equal to Yx. That was also given. So I've got two sides. I'm thinking side angle side, I probably need an angle. Well, what angle do I know? Angle VXW. And that's going to be equal to angle YXZ because they are vertically opposite. I know there's a tendency for us to want to write X rule, something like that. Try and learn the mathematical terms for them because they may come up in your external exams and you need to make sure you're aware of them. Either way, we've got two angles and the side in between, two sides and the angle in between, let's get that right. Therefore, triangle WXV is congruent to triangle ZXY by the side angle side rule. Now, I haven't finished, hence deduce the values of C and D. Well, all of those diagonal side lengths are equal to each other, the short one, so C is going to equal 15. And angle D is going to be 180 for the triangle. I know this is a 70 here. Minus 70. And then divided by 2. Because this is isosceles, that other angle must also be D, so I can do either one. Half of what's left over, D is going to be 55 degrees. And you're done with question 6. Alright, I think these are the last two simple familiar questions. I might stop the video after that one and start a new one because this one's going on a bit. But we'll do the last two. Angle SRT is 53 degrees to the nearest degree. ST is 17 centimetres to the nearest centimetre. So someone's done some measuring and they've rounded or estimated their values. We want to calculate an upper bound. The upper bound for RS. Well, RS is the hypotenuse. So really that's what I'm finding the upper bound of. That side there. This is an opposite side. Given this angle, that's the adjacent. So I'm thinking opposite and hypotenuse, that's sine. SOHCAHTOA. SOHCAHTOA tells us sine is the opposite over hypotenuse. That's what I'm after. So I start with that. Sine of 53 degrees equals the opposite side, 17, divided by the hypotenuse, which is what I'm looking for, which is RS. A little bit of rearranging. RS sine 53 equals 17. I'll go through the steps slowly this time. I skipped them on the previous trig question. Let's make sure I'm kind to you this time. So 17 over sine 53. Now I want to find the upper bound. Now this is where you had to do a little bit of thinking. For the upper bound of RS, if I've got a fraction here, I need to have the biggest possible number on top and the smallest possible number on the bottom. That's how I'm going to end up with the largest quotient, the largest answer from doing that division. So the largest number, I want to find the maximum here, but I want to find the minimum value there. So the maximum that could have been was up to 17.5. Now we've talked about this when we're doing our limits of accuracy. Yes, 17.5 would be rounded to 18, but we could say that this is definitely the upper bound. The length of RS is definitely going to be less than whatever this number is. It could only just be the tiniest little fraction less than, but we know this is the upper limit to what it could be. So 17.5. To have a minimum value for sine 53, well, sine 52.5 is smaller than sine 53.5, so I need to make that sine of 52.5. That will give me the upper bound of RS. That would be fine, you know. I'm actually happy with that right there if you left your answer like that. But I know most of us will want an answer somewhere. Let's see where I've got one. RS would be, the upper bound would be 22.058. Oh, let's call it 0.6. Why not? Centimetres. That would be the upper bound of length RS. Alright, one more I said I'd do. The length of the line joining 3, -2 and K10 is 15 units long. Find the possible values of K. So we're just using our distance formula. The distance equals, it's just Pythagoras' theorem, isn't it? K minus 3, that's the difference between the x coordinates squared, plus the difference in the y coordinates, 10 take -2 squared. So my distance is going to be, we know the distance. It's 15. 15 equals the square root of K take 3 all squared plus 144. Well, I can square each side to get rid of that pesky little square root. So I'm going to have 225 equals k take 3 squared plus 144. Do my subtraction. What I'm actually going to... yeah, I'm going to do it my way. I'm going to subtract the 225. When you've got a power there, you want to try and remember to set it equal to 0 and factorise. So I'm going to be left with k minus 3 squared minus 81. 81 is, of course, 9 squared. You could write that as a second line if you want. I'm just going to do it there for you. Difference of two squares. I told you it was our favourite rule in maths. Saves us more time than any other rule. K minus 3 plus 9, k minus 3 minus 9. What am I left with there? K plus 6, k minus 12. Null factor law. Either that first bracket must equal 0, k equaling negative 6, or the second bracket has to equal 0, k equals 12. So negative 6 or 12 are our answers. All right, I'm done with that one. That was a little bit of a marathon, but not too bad. 16 minutes, if you did your exam that quickly, you would be flying. You'd have heaps of time to check your working. And you could probably do it even faster if you didn't have to stop and explain things along the way. All right, I'll be back with the rest of the exam in the next video. Catch you then.